Hi, this is lecture number 3 on infinite series. Concepts to be covered in this lectures are comparison test, p-test, we also call this harmonic p-series, and then examples based on comparison test and p-test. So we start our discussion with comparison test. So let summation an and summation bn be series of non-negative reals. Non-negative real numbers. Assume that an is less than equal to bn for all n in n. Then if summation bn is convergent, then summation an is convergent. An is convergent. Second, if summation an is divergent, then summation bn is divergent. So it is the contrapositive of first condition. What is the contrapositive? If an is not convergent, then bn is not convergent. Series bn is not convergent. That is, if summation an is divergent, then we can prove this second part by taking the contradiction. If summation an is divergent, then bn is divergent. So if we take summation bn is convergent, then we can prove that summation an is also convergent. So it contradicts the condition that what is given, that summation an is divergent. So let summation bn be a series of positive real numbers. Be a series of positive real numbers. Assume that summation n bn is n means n equal to 1 to infinity, right? Is convergent and there exists a positive real number m belongs to n such that positive natural number or we can say positive integer m belongs to n such that mod of an is less than equal to bn for all m belongs to, or even instead of taking m we can take natural number n, right? For all n in a, for all n in n. Then summation en is absolutely convergent. Absolutely converged, and hence converged, and hence converged. So by comparison test, if Bn is convergent, summation Bn is convergent, it is given. So where we can use the comparison test. What is the how we can use? By first condition, if An is less than equal to Bn and summation Bn is convergent, then summation An is convergent. So here, if given that if Bn series is convergent, then summation mod An is convergent. So we can say summation An is, if the mod of the series is convergent, then we can say it is absolutely convergent. The series is absolutely convergent, and hence it is convergent. Next is harmonic P series. Harmonic P series. So consider, even before discussing harmonic P series, we have comparison test 2. Comparison test 2 is very useful while solving problems related to comparison test. Comparison, so we can say comparison test 2. So let summation An and summation Bn be two positive term series. Be two positive term series. So if limit n goes to infinity, An upon Bn, it is equal to some number L. Here L is finite non-zero constant. L being finite non-zero constant or real number. Then the series summation An and summation Bn both converges or diverges together. So if summation An is convergent, if limit of An upon Bn equal to some finite non-zero finite number, then both the series either convergent or divergent. Second, if limit n goes to infinity, An upon Bn, that is equal to 0, and summation Bn is convergent, and summation Bn converges. Summation Bn converges, then summation An also converges. So in second case, if the limit of nth term of series An and nth term of series Bn, if we take the limit of An upon Bn, if it is equal to 0 and summation Bn converges, then An also converges. If limit n goes to infinity, An upon Bn, that is infinite, and summation Bn diverges, then summation An also diverges. So these are three very important points related to comparison test. Now next is harmonic P series. Harmonic P series. So consider the series. Consider the series summation n 1 upon n की power p we claim that harmonic P series is divergent if 0 less than p less than equal to 1 and is convergent if p is greater than 1. So we can write this as P test. What is P test now? If we have a series if the series summation 1 upon n की power p for p greater than 0. So if we have the series this, then it is summation 1 upon n की power p converges for p greater than 1 and summation 1 upon n की power p diverges for p less than equal to 1 but greater than 0 because p is greater than 0. So we can, this is P test. So we have discussed two tests, comparison tests. En and Bn are two series of non-negative real numbers. En is less than equal to Bn. If summation Bn is convergent, then summation En is convergent. If summation En is divergent, then summation Bn is divergent. And third, if we have a series summation Bn of positive real numbers and assume that if this series is convergent, then there exists n in n such that mod an is less than equal to Bn for all n in n. Then summation an is absolutely convergent and hence it is convergent. So now comparison test 2, if we have two positive real number series, positive term series, so if we find the ratio of an and bn, nth term of if we consider the nth term of summation an and nth term of summation bn, that is an and bn respectively, if we take the limit n goes to infinity an upon bn and it is equal to some number l. L is not equal to 0, L is not equal to infinity because we are separately discussing about the case when L equal to 0 and L equal to infinity in second and third part, right? So in first part, L is not equal to 0 and L is not equal to infinity. So what is the value of L? L must be greater than 0. Why? Because we have positive term series. If the series convergent, if we have a positive term series, if it is convergent, then it converges to a positive number, right? Or if it diverges, then it diverges to plus infinity. So we separately discussed 3 cases, and then we talk about p-test. So now, what happen if we take p to be less than equal to 0? If p is less than equal to 0, then what happens? So we have a series summation. Let summation an is equal to summation 1 upon n to power p, right? Or and p is less than equal to 0. So here the nth term is 1 upon n to power p, that is equal to n to power minus p. So because p is less than equal to 0, so if we take p to be 0 or negative, then it is n to power minus of p, it is positive one, right? So what this implies that if we take the limit of an, then it is not equal to 0. So we have already discussed one case. If the series summation an is convergent, if it is given, if an is convergent, then limit n goes to infinity, an is not equal to an equal to 0. What is the contrapositive of this? If limit n goes to infinity, an is not equal to 0, then summation an is not convergent, is not convergent. So now we have summation limit n goes to infinity, an is not equal to 0. This implies that summation n is not convergent. Is not convergent. So this implies that summation n is divergent. So series diverges for p less than equal to 0. So method to apply comparison test. This is for p less than. Method to apply comparison test. How we can apply comparison test in numerical? So an and bn, if we have two series, summation an and summation bn, right? So an is the nth term of series, nth term of series summation an, and bn is the nth term of series bn. So in case an be expanded, in ascending parts of 1 upon, then take bn equal to lowest power of 1 upon. If we expand the series in the ascending parts of 1 upon n, then what is our bn? We can take bn to be the lowest power of 1 upon. Also, bn is equal to 1 upon n to power p, where p is degree of denominator minus degree of numerator in series year, right? In year, series year. Or we can find the nth term. So from nth term, we can find degree of denominator minus degree of numerator. So this is our BN. For example, let us discuss one example. If we have a series, discuss the convergence or divergence of the series 1 upon 1 into 2 into 3 plus 1 upon 3 upon 2 into 3 into 4 plus 5 upon 3 into 4 into 5 plus 7 upon 4 into 5 into 6 plus so on. If we have a series, we have to discuss the convergence or divergence of the series. The given series is 1 upon 1 into 2 into 3 plus 3 upon 2 into 3 into 4 plus 5 upon 3 into 4 into 5 plus so on. So we can write this as summation n equal to 1 to infinity, because numerator, the terms in the numerator are 1, 3, 5, so we can write 2n minus 1 divided by n into n plus 1 into n plus 2. So if we put n equal to 1, then we get the first term. If we put n equal to 2, we get the second term similarly. So what is the nth term in this series? So here an is equal to 2n minus 1 divided by n into n plus 1 into n plus 2. This is the nth term of the series. Now we have to check whether the given series is convergent or divergent. So what we do, we find the auxiliary series. So auxiliary series from where? From an. So the auxiliary series Bn is equal to, what is Bn? That is 1 upon n ki power p. So n ki power p means p is degree of denominator minus degree of numerator. So the highest power of n in denominator is n into n cube, that is 3. And highest power of n in numerator is 1. So 3 minus 1 is 2. So we can take Bn to be 1 upon n square. Right? 1 upon n square. Here p is equal to 2. So how we can get p? P is degree of denominator minus degree of numerator. Degree of denominator is 3 minus numerator is 1. So that is. So in this way we can choose Bn. So now what we do? We have to find An upon Bn. Now we use the comparison test 2. Comparison test 2 is very important. So we find An upon Bn, because both An and Bn are positive term series. So now we find An upon Bn, that is 2n minus 1 divided by n into n plus 1 into n plus 2 into n square upon 1. So 1 and n cancel out, so we can take n to be common. So n square is common, 2 minus 1 upon n Again, from denominator, we can take n to be common. So we can write this as n square cancel out. So now we find the simplest form of an upon bn. Now we apply the limit. Limit n goes to infinity, an upon bn. That is, limit n goes to infinity, 2 minus 1 upon n divided by 1 plus 1 upon n into 1 plus 2 by n. And that is 2 minus, when n goes to infinity, 1 upon n goes to 0, 1 plus 0, 1 plus 0. So that is equal to 2. And now what is, when we revise the comparison test 2, so this is the first case. If limit n goes to infinity, an upon bn, that is equal to L, where L is non-zero finite number, or even we have a positive number because the terms are, both terms are positive. So this is 2, which is non-zero, finite number, finite positive number, positive real number. So by comparison test, comparison test 2, what we can say, both series summation an and summation bn are convergent or divergent together. Both either convergent or both divergent together. But summation bn, what is bn? Bn is 1 upon n square. So what is summation bn? Summation bn is summation 1 upon n square. Now we apply the p test. So if we take the value of p to be 2, it means it is greater than 1. Then what happens? Summation 1 upon n square, it is convergent. So by p test, we can say is convergent, is convergent by p test for p equal to 2, which is greater than 1. Now comparison test 2. Comparison test 2 says both series summation an and bn are convergent or divergent. So both have the same behavior. So we know the behavior of summation bn. What is the behavior? It is convergent. So now we can say, thus by comparison test, we can say summation an is also convergent. So hence the given series is convergent. So in this way we can solve problems related to comparison test. Second example is discuss the convergence or divergence of the series summation log n power 65 upon n की power 6 upon 5. So if we take this series, let summation an is equal to summation log n की power 65 divided by n की power 6/5 if we have seen. So here an is equal to log n की power 65 divided by n की power 6/5. Now in this case we can take bn. How we can take bn to be, I can take bn to be n की power 11/10. How we can take this? Because in we have p to be greater than 0 uh, for convergence. Yeah. So here p is choose p such that p means for bn equal to 1/n की power p. We can choose p such that p lies between p is greater than 1 but less than 6/5. Now how can we choose this such type of p? So we have to find the value of p to be in between a and b. And in first chapter, if we have already discussed, if we have two real number a and b, we can find a number c in between a and b. That is the arithmetic average of a and b. So what is this c? C is a plus b by 2. And a plus b by 2 is strictly lies between a and b. Right? So now, based on this, how can we find this p? So this p is we have to find p is greater than 1 but less than 6/5. That is p to be equal to 1 plus 6/5 divided by 2. Average of 1 and 6/5. It is 11/5/2. So it is 11. So in this way we can take p to be 11/10. So our bn is 1/n की power 11. Now when we find bn, then we can find an/bn. an/bn is log n की power 65 divided by n की power 6/5 into n की power 11/10 upon 1. Okay. So log n की power 65. So after solving, what we get? We get n की power 6/5 into n की power -11/10. That is log n की power 65 divided by n की power 1/10. And this is equal to when we apply the limit n goes to infinity, an/bn, limit n goes to infinity, log n की power 65 upon n की power 1/10, that is equal to 0. How it is 0? Because limit n goes to infinity, log x की power not n but x goes to log limit x goes to infinity, log x की power m upon x की power n. This is equal to 0 for all n greater than 0. So here n is 1/n, which is greater than 0. So we apply this result. So if limit is equal to 0, now we apply the comparison test 2. What is comparison test 2? That is, and bn converges. If bn converges, then an also converges. So bn is now we check whether Bn is convergent or not. Now summation Bn. Summation Bn is summation 1 upon n की power, what is Bn? 11 upon 10. And 11 upon 10 is greater than 1. So by p test, it is convergent by p test for p equal to 11 by 10, which is greater than 1. Thus, summation an is also convergent. Okay? The given series is convergent. So example 3, summation discuss the convergence or divergence of 1 upon log n की power log n. So if we take summation an to be summation 1 upon log log n की power log n, if we take this series, right? So here the nth term, if we compare the nth term, then nth term is log n log n की power log n. This is the nth term. So let log n की power log n to be equal to n की power theta. So let this be. So taking, let this is important, so I we take this v bar. Taking log on both sides. Taking log on both sides, we have log of log n की power log n, that is log n की power theta. So we know that log n की power n, that is n log n. So we can write log n of log log n, that is equal to theta log n. So log n is cancelled out. So we can write log of log n, that is equal to theta. Right? So now if we apply the limit as n goes to infinity, as n goes to infinity, theta goes to 0, theta goes to infinity. Right? So theta goes to infinity as n goes to infinity, because log of infinity, log n goes to infinity as n goes to infinity. So this term become infinite. Log of log n become infinite when theta when n goes to infinity. It means theta goes to infinity as n goes to infinity. Therefore, it means it is divergent. Log of log n is divergent. It diverges to plus infinity. It means there exists a positive number m belongs to n such that for all n greater than equal to m, we have theta is greater than 2. Theta is always when, because log is log of 2, log is increasing increasing function. So we have theta must be greater than 2 for all n greater than equal to n. We have we find a positive number m such that for all n greater than equal to m, but we get theta must be greater than 2. So if we find theta to be greater than 2, so what is n ki power theta? It is also greater than n ki power theta. It is also for all n greater than equal to. Now since from equation 1, what is our n ki power theta? It is log of log n ki power log n. So we can say log of log n ki power log n is greater than n square by 1. Now if we take the reciprocal, so 1 upon log of log n की power log n is less than 1 upon n square, and this is true for every n greater than equal to n. Now we apply the comparison test. We have one series an, another series bn. If bn is convergent, then an is also convergent. So now we apply the comparison test. Since summation 1 upon n square is convergent by p test for p equal to 2, which is greater than 1. Thus, by comparison test, we can say that series summation 1 upon log n to power log n is convergent. So in this way we can prove that this series is convergent series. Example 4. Discuss the convergence of summation n cube plus 1 under root minus summation minus under root n cube. So we have to discuss the convergence or divergence of this series. So if we compare this series, then we can compare this series with summation an. We can find an to be under root n cube plus 1 minus under root n cube. So we can rationalize this n cube plus 1 plus n cube plus 1 n cube. So this we get n cube plus 1 minus n cube divided by n cube plus 1 plus under root n cube. So this is cancelled out, so we can write this as 1 upon n cube plus 1 plus under root n cube. So we can simplify this. We can take n to be common from denominator. So n is n ki power 3 by 2. We can take n ki power 3 by 2 to be common. So in first term, it become 1 plus 1 upon n cube. And from second, we can take this common. So here we have 1. Now this is our an. Now we have to find the auxiliary series bn. Bn to be 1 upon n ki power 3 by 2. Degree of denominator minus degree of numerator. So an upon bn, and so 1 upon n ki power 3 by 2 to be cancelled out. So we have only 1 plus 1 upon n cube plus 1. When we apply the limit, limit n goes to infinity, an upon bn, that is we get, after applying the limit, we get 1 plus 0 plus 1, that is 1 upon 2, which is non-zero finite number, non-zero finite positive number, positive real number. So by comparison test 2, we can say by comparison test 2, both the series summation an and summation bn are convergent or divergent together. Now we have to check the behavior of series bn, but summation bn, that is summation 1 upon n की power 3 by 2, which is convergent by p test for p equal to 3 by 2, which is greater than 1. Thus, summation an is convergent by p by comparison test is convergent. So let us discuss one more example. Discuss the convergence or divergence of the series summation cube root of n cube plus 1 minus n. So here, if we take this series to be summation an, then the nth term an is equal to cube root of, so we can write this as n cube plus 1 की power 3 by 2 minus n. So if we take n to be common here, so n cube, if we take n to be common, oh sorry, it is not 3 by 2, but it is 1 upon, not, it is 1 upon cube root. So if we take n to be common, then we can take n cube की power 1 upon 3, 3 and 3 cancel out, so we can take n to be common. So 1 plus 1 upon n cube की power 1 upon 3 minus n. So again we can take n to be common from both the terms. We can rewrite this. So by using binomial expansion, we can write this as 1 plus 1 upon 3 into 1 upon n cube plus 1 upon 3 into 1 upon 3 minus 1 upon 2 factorial into 1 upon n cube the square, 76, plus so on. And then minus 1. So 1 and 1 to be cancel out. So we have n into 1 upon 3 into 1 upon n square n cube plus 1 upon 3 into minus 2 by 3 upon 2 into 1 upon n6 plus 1. So we can take 1 upon n cube to be common. So 1 upon n square 1 by 3 plus minus minus 1 upon 9 into 1 upon n cube plus so on. So now we can take bn to be 1 upon n square. So now an upon bn, that is 1 upon 3 minus 1 upon 9 n cube plus 1. So if we apply the limit n goes to infinity, an upon bn, then we get only 1 upon 3, which is non-zero finite real number, non-zero finite positive real number. Thus, by comparison test to both an and summation an and summation bn are converges or diverges together. But summation bn, summation 1 upon n square, that is equal to summation 1 upon n square convergent by p test for p equal to 2 is equal to 1. Thus, summation an is also convergent. So in this way, we can check the behavior of the given series. So now try to solve examples related to comparison test and p-test. We will discuss about Cauchy root test and D-Lambert ratio test in the next video lecture. Thank you. Have a nice day.